Illustration 3, we have a three-phase transmission line delivering 5,000 kilowatts at 22 kV at 0.8 power factor lagging. The resistance and reactance of each conductor is 4 and 6 ohms respectively. We have to get the sending end voltage, percent regulation, and the transmission efficiency. Okay, so since this is a three-phase transmission line, so we know that we just need one phase for our analysis, no? Although perhaps the sending end voltage that we need here is the line-to-line quantity. Okay. So in this case, our Vs is equal to VR plus IRZ, only that our Vs there is per phase, VR is per phase, and your Z is also per phase, and then your IR is our line quantity. Okay, so VR will be over 22,000 over square root of 3. Okay, so because we need the per phase quantity. Okay, so 0 degree pa rin naman siya because VR is our reference. And then for our IR, we make use of our concepts in AC circuits, Okay, so and then our angle is again negative, cosine inverse of 0.8 because the power factor stated here is lagging. Okay, so your Z is already given as 4 plus J6, no? So everything plug in our Vs equation, we will get the per phase Vs. Okay, so if we will be needing the line-to-line quantity, so we just have to factor in square root of 3 times the per phase quantity, diba? Okay, so in this case, we have 23.9 kilovolts, angle 1.63 degrees. Okay, so ang difference lang niya sa single phase, because this is three phase, per phase tayo, per phase quantity yung Vs. Automatic yun, na Vs is the phase quantity, na. Okay, next is for the voltage regulation. Okay, percent regulation, sabi kasi dito, no? So voltage regulation yun. Okay, so it will be, since this is a short transmission line, so Vs minus VR over VR ang gagamitin natin. Okay, so the computed Vs will be plugged in here. Okay, so diba yung Vs natin here, this 13.822 is the per phase. Okay, so therefore yung VR natin will also be per phase. Okay, and then we get VR as 8.825%. Okay, so we can also get VR in terms of the line quantities. Okay, so yung 13.822 natin kanina, we get the line quantity 23.9. Right, and then 22 over 22. Okay, so again, yung percent voltage regulation, either we just have to be uniform, no? Either we use the per phase quantities or the line-to-line quantities. Okay, so next we have the efficiency, PR over PS. So yung PS here, because this is now a three-phase transmission line, so we factor in square root of 3 if we will be using the line-to-line quantities of Vs and Is. Or pwede rin namang per phase, Vs, Is, phase times 3. Okay, for the total PS. Okay, and then we have to get PF of the sending end. So again, write the phasor diagram, and then this Vs, which is theta 1 from VR, and then your Is, which is again equal to IR, and then theta 2 from VR. So the angle between Vs and Is is your theta S. So walang problem na in terms of getting the power factor of the sending end, no? Okay, so with this, we get efficiency of 93.93%. Okay? Okay, so there's another way of getting the efficiency, which is like what we use kanina, in terms of the PS, which is in terms of the losses. Okay, so PR plus 3I squared R, which is your line losses. Okay, so sa single phase 2I squared R, so sa 3 phase 3I squared R. Okay, so this is the total line losses, no? Kaya siya 3 times 3. Okay, so since we have I rin naman, yung I natin is the line. So in this case, it will be your also your IR kasi IS is IR, no? So we'll have the efficiency as also 93.93%. Okay? Okay, by the way, the I that we are referring here for the line losses is the current that is flowing through the series impedance dun sa line. So, it so happened here that yung current that is flowing through Z is IS, which is also IR. Okay? So, you have to take note of that, no? So, the current flowing here kay R or kay Z, yun yung current that we need for the line losses. Okay? So, I hope it's clear.